Hello, guys. Good evening. Hope everyone is doing good today. So, today we are covering up on the fourth part of our Python interview series. So, before we jump into the video, just a quick intro. Who are we? We are Data Valley, the fastest growing edtech company of 2025. And myself, I'm Franklin. I have almost 3+ years experience as a data engineer. So, I feel glad to bring in demand and this is all happening in the industry, right? This is not something we make up, but this is happening in the industry, and I'm very glad to bring these kind of videos to you. If you're in LinkedIn, feel free to connect with me, and let's build our network. So coming back to our Python interview series, we have already covered up three parts in this. If you're new to this video, I recommend please go and check out the previous videos so that you'll get an firm foundation, so you're not missing out on the fundamentals. So I recommend you go to the previous videos, have a quick look up what we have discussed and how we have progressed from starting from what is Python to further we are building it. So people who have been following it regular, thanks for coming back again. So if you like this video, please like it. If you have any questions, also feel free to share your comments. When I do my next series, I will definitely follow up on your question. And then do not forget to click on the bell icon so that you don't miss on the regular updates. And okay, before we jump onto the video, you all know the routine. What is it? Grab a cup of coffee, because you would have been exhausted already, right? Because you might be a college going student, you might be a working professional, and at the end of the day, after five, when you finish your job or your college. And recently I came to know that even school students are coming to watch these kind of videos. But yeah, it's good, it's good to learn always. So please feel free to refresh yourself, have grab a coffee, have your notes prepared, grab a make sure that it's silent everywhere, and you tell your parents, do not disturb me for an hour because I'm going to be focused in learning Python. So they wouldn't disturb you. We all have a good parents, don't we? So do follow up on these. So without further talking, let's jump to our video for today. So today we are starting on our fourth part of our Python interviews. I hope you can hear me, just in case. Yes, everything is well. We already have seen a bit of functions in relevance to your Python programming, right? In our previous video we discussed on a few list operations, like what is a list in Python, what are the key characteristics of a list, and then we saw few methods and functions which are built in. So we saw how to append an element to a list, how to add all the elements of an iterable to a list. So you use an extend function, right, rather than append, because in append you add it as a single element. In extend you get to add each element individually. Then you saw how to insert an element based on the index numbering at a specific position. Then you also saw about how to remove an element from the list. Then you saw the difference with pop, because pop differs in a way that you mention an index number and it is going to remove that particular element. If you haven't provided it, it is going to remove the last element of your list. Whereas in remove, it'll just remove an element at its very first. Then you saw how to empty an list. Then also we touched a brief on indexing methods in list. So how are you going to find an index of an element? So you just provide the value and your code is going to run, and it is going to specify what is the index of the element you are looking. All right, so this is our second part of the list series. So let's jump to it. The first thing we are going to look in today is what is count function. Okay, what is a count function? So count function in Python list is a built-in method that returns the number of times a specified element appears within the list. So what's going to happen is you're going to find the repetition of elements that's in a list. For instance, a list might have duplicates, right? There are chances that it might have a duplicate value, and you would like to know that for a particular element, or the particular duplicate element, you would like to know that how many times has it been repeated, what is the total count of these elements within a list. In that case, you have to use the count function. So as it says here, it is used to determine the frequency of a particular value within a list. So you want to know the exact count of the particular value or the element within a list. Talking about the syntax is very simple as we have seen it previously. It goes like list name dot count and the value what you're looking for. So what is list here? So list specifies in what list would you like to check the frequency of an element. So you provide the list name here, and then you use a dot notation, and then you use count function to specify the value within a. So this count function is going to take a value as an argument. Okay, let's talk about the parameter. And the value parameter, this is the argument which is going to say that look for this element within the list. So the element whose occurrences you want to count in the list. So it can be any element. And if you are aware, lists support mixed types, right? So it can take string type, it can take in integer type, it can take boolean. We have different types, float, which is being supported in a list. And then whatever the value it could be, you just have to specify it within the count function. So your syntax is very simple. And then what does it return? The count method returns an integer representing the number of times the value appears in the list. If the value is not found in the list, it returns. As you all know that the count function is going to give you the count of a particular element. Talking about the count of a particular element, when I try to say what is getting repeated, what is the frequency of an element getting repeated, so how would you represent it? How would you represent a repetition of an element? So you use an integer to represent the repetition, right? So a count is always going to be a number. So the return value for a count function is a integer. So it always returns an integer that represents the number of times the value has been appearing in the list. The value is not found in the list. It is going to return us with 0, which is still an integer. Okay, let's check how it works in our code. All right, so first I am creating a list. Okay, let me create a list. Okay, it's taking a bit of time to work on it. Let's wait till the code gets run. Okay, I think it is ready. Okay, cool. We have created a list, and as you can see that we have got elements like 1 comma 2 comma 2 comma 3 comma 4 comma 2 and comma 5. All right, so that's how our list looks. And to our naked eye we can see that how many times a particular element has been repeated, and it is very easy to calculate. When talking about a large data set, it is going to be a tough process for you to keep track of the frequency of elements in a list. So that's why you have to use a count function. For in the above code, let's see how to implement the count function and check how many times the value number 2 has been repeated in the list called my list. So I've got a variable here, right? Because my count function is going to return an integer. So I want to take this integer out, and then if I could take it out, then I can print it in my statement, right? So what I'm doing, I'm creating a variable called count of 2, and then I'm applying my syntax here. So your syntax goes like your list name dot notation, your count function, and the value that you're looking for. So that's the argument. So in here I want to check what is the frequency of occurrence of number 2. So I've put in my value as 2 here, and then I'm printing it, and now it says to me that number 2 appears 3 times. Is it right? Yes, because see here, 1, 2, and this is the third time. So number 2 is appearing 3 times in our list called my list. And then okay, there are multiple occurrences, so 2 is fine. What if there is just one element? It still is going to give you an integer, and it is still going to give you the same count. So instead of 2, I've just applied 5 here. Let's see what our code returns. It returns that okay, number 5 is appearing just one time. Let's talk about a different scenario where we don't have the particular element within a list. So I've already explained it to you. When a particular element is not found within a list, it is not going to raise an error. It is just going to give you an integer, again a number 0, which is going to say to you that yes, the number just occurs 0 times, which means that you don't have that particular value in the list. So for the above example, with the same code, I've just changed the value here, just changing the value to number 10. I've also given a different variable if you haven't noticed. So I've given count of 2, count of 5, count of 10. Make sure that you write your variables in a way that you can understand, it makes sense to you. you always cannot just write x and y values or z values, right? You always have to make sure that your variables have a proper naming that makes sense. So do we have 10 in our list actually? So we have 1, 2, 2, 3, 4, 2, and 5. We don't have 10. Let's see what happens when I try to run this code and asking for the element number 10. And you can see that number 10 is appearing 0 times within our code. So we haven't raised any error, but we have just returned an integer for the 0 value. Okay, let's talk about our next method, and that is sort method. What does sort basically mean? Sort, what do you call a sort to be? So sort is where your elements are going to be sorted in a particular order, right? So sorted is like organizing your elements in a list in a proper way that it makes an order. For example, it could be in a different order, like let's say it's an ascending order. You want it to be in descending order. So it doesn't matter, even if it is an ascending order or descending order, it is still an order. So the process of making your elements organized, or the process of sorting a element based on certain criteria, is the functionality of a sort method. Okay, let's go by the definition. The sort method in Python is a built-in method specifically designed for lists, allowing for in-place sorting of their elements. So the key points here are: sort method is a built-in function. All right, and now you gotta understand this. It is going to allow for in-place sorting of your element. So what does in-place sorting mean? So whatever the original list that you pass on to a sort method, it is going to alter your existing list rather than creating a new list for you. So be sure that when you apply a sort method, it is going to give you an in-place modification. So better use it in the right way, because you don't want to collapse your rows, right? If it is carrying some kind of value to it, you don't want to spoil it, you don't want to alter it. So make sure that, because this is an in-place modification, use it wisely. Let's talk about the key characteristics of your list.sort method. As I said earlier, it is an in-place modification. Unlike the sorted function, do not worry about sorted function. We will cover it in our later chapters. But what we are trying to see here is a sorted function is different to a sort function. So what happens in a sorted function is different to what happens in a sort. So sorted and sort function. And right now we are talking about sort function. So be sure about it. So in sorted function, what happens? You return a new sorted list. So where you need to return a separate sorted list, you use a sorted function. But in sort function, it modifies your original list. Instead of returning a new list, and it returns a none value. Okay, so it modifies the original list directly and returns none. This means that the original list is altered to reflect the sorted order. So because we have an in-place modification, what does it imply? It just says that your sort function has taken place and it has been reflecting in your list, as you can see. Then talking about our next characteristics: default ascending order characteristics of a sort function. What is the default ascending order? So you all know what is an ascending order, right? So if you consider numerical values, for instance, let's say I have 1, 3, 5, 2, and 4. If I have to sort this based on ascending order, what is the order? So it goes like 1, 2, 3, 4, 5. So from smallest to your highest. So that is how your ascending order is. Talking about alphabetical values, let's say I have three names. Let's say I have Raj, I have Frank, and then I have Michael. So if I try to arrange this in an alphabetical order, so Frank is going to come in first because F comes, then I'm going to have Michael because M comes before, which is, so I'm sorting it based on my alphabetical order. By default, sort method is going to support for your ascending order, but it doesn't mean that it just supports ascending order. There are ways that where you can reverse the way it works. What I'm trying to tell here is that, for instance, let's say your default is ascending order, but you want to get an descending order, and that is where you use optional parameters to work to get the descending order for your sorted. Talking about our optional parameters, we can use two kinds of arguments for our optional parameter. So for instance, if I specify reverse is equal to true, then the list is going to be returned in a descending order. What is the default sorting order for your list? It is ascending order, right? When I try to use the optional parameter reverse, you are reversing the ascending order. And what is the reverse of an ascending order? It is the descending order. So you have an optional parameter called reverse is equal to true. And then the next parameter is key. So key, what happens with the key is that it is going to accept a function that is applied to each element before comparison, allowing for custom sorting criteria. So what I'm trying to tell here is you have an optional parameter called key, and then using key you can specify certain function with which the each of the element is going to be, so each of the element will be compared against this key function, and then your sorting criteria comes into play. So based on whatever the key function that you provide, your sorting is going to happen eventually. So for example, one of our key function could be a sorting your list by the length of the string. So for example, in our previous example that I said, let's say I have three different names in my list: Frank, Raj, and Michael. So if I'm trying to use a key function here, so for example, let's say I'm trying to sort based on my length. Okay, so if I'm providing key is equal to length function, so if I provide my length function, what's going to happen is for each of my element within a list, Frank is going to have 5, so that is the length of my that particular element. Michael is going to have, so Michael, so that is 7 letters. So Michael is going to have 7 letters, Frank is going to have 5 letters, and the other name is Raj, and Raj is going to have 3 letters. So what would happen if I'm trying to sort this based on my key function? So by default it is ascending order, therefore it must be ordered in a way that 3 5 7, because you're using length function to sort your list. By that you must have Raj, you will be having Frank, and then Michael. So there are different ways. So you saw how to do ascending order for your list, you learned how to do descending order for your list. Also then you can specify different criterias using the key functionalities to specify how your sorting must be performed. Let's jump into a code to have a look on it. So first thing, I've created a list here. As you can see here, my list is not sorted on any order, right? So my list goes like 3 1 4 1 5 9 2 6. So they don't have any corresponding meaning to it. It is just as it is, right? And now let me print the list so that you have a look. So if I run my list, you can see that I've got the same order, right? This is how it is. This is my original list. So what's going to happen now is I'm going to use sort function. By default, what does it imply? It implies ascending order. And then I'm printing my list. Why am I printing my list again? Just to show that it supports in place modification. All right. So okay, let me run this code. So now this was my original list, and now when I used sort function, so this is our notation, right? Your list name dot sort function, and then when I print it, I can see that it has changed. So there has been an in place modification. So rather than printing 3 1 4 1 5 9 2 6, my list has printed me that 1 1 2 3 4 5 6 9, which is in ascending order. And then you can be very sure that an in place modification has been taken place. Okay, now let's try a different list, and then let's try to print our list in an descending order. All right, so as you can see here, I've got a list here which is called as another list, and it has got 3 elements. So because we have seen integers already, now let's cover about string type. Okay, the alphabetical one. So I've gotten another list which is having 3 elements: banana, apple, and cherry. I've used double quotation because characters or your alphabeticals must always be used with a single or double quotation marks because they are strings in Python. Okay, so if I print this list, what does it print? It prints me banana, apple, and cherry, which is good, which is perfect. That's how we have provided the order for elements. But now what we'll do here is we will try to use sort function, as you know already. By default, you know that it supports ascending order. To reverse my ascending order, I can use an optional parameter, as you have seen here already. So optional parameter reverse is equal to true, which will give you the list in the descending order. So what I'll try to do here is I'm sorting it based on the descending order. So when I try to run on this, by guess you all know that banana, apple, and cherry. If you use descending order, it is going to be cherry, banana, and apple, right? So now let's print it and check it out. So now you can see that cherry, banana, apple. So our original list was banana, apple, cherry, cherry, banana, apple. Just in case if you're not sure, because I'm printing it next to my function, I'll make it very clear to you. So no matter what, even if I print later, it is going to be in reversal order. Why? Because it is in place modification. Your original list has been altered completely. So you cannot expect, when you run your code later, you will find the original list that you actually given as an input. But rather, whatever is modified, whatever the latest part is, that's what you'll get to see in your another list when you print it. Now, I already said you about using key function, right? Which is again an optional parameter. What does a key function do? It takes in an function, and then based on that, it gets applied to each element. And once it gets applied to each element, then you get to compare, and then you sort it based on the criteria that you provided. In that context, now I've got a list here. I've got a list called words, which is having four elements: apple, banana, kiwi, and so those are fruits, and they do not have any particular order in them. So apple, banana, kiwi, and grape, they are unordered. Unordered in the sense that they are not sorted. And now when I print it, just to show that again, in place modification, I'm just printing it. It's going to just replicate the same. And now what's happening here is I'm using my sort function. So your list name. So what is my list name here? It's words. So my list name dot sort function. And then for the key, I'm going to provide my function with which I want my elements to be compared. So key is equal to len. So I'm going to sort it based on the string length. And when I print it, you can see that it has been ordered based on the length. You might be wondering, why has it printed kiwi, apple, grape, banana and not banana, grape, apple and kiwi? As you already know about the functionality of a sort method, it is always going to print based on the ascending order. So by default, you will have ascending order unless you specify your optional parameter reverse is equal to true. And when you specify optional parameter reverse is equal to true, you're going to get the descending order. All right. So we have seen how to sort your list in ascending order, in descending order, and using a custom sorting criteria like key functionality. And then now let's talk about how to reverse. So what do I mean by reverse? So reverse method, again, it is an inbuilt method in the Python list. It modifies in place by reversing the order of its elements. So what's happening here? It is going to give us an in place modification, and it is going to alter based on based on the function that we have provided. It is going to give us in place modification, so be sure about it. It is not going to give us any what do I mean, any new uh, different list or updated list, but rather it's an in place modification. Let's talk about the key characteristics. So first things first, it is having an in place modification. I'm damn sure that you all know about in place modification. What happens in an in place modification? By using dot reverse method, it alters the original list, and it does not create a new list with the reversed elements. So what am I telling here? The reverse method directly gets applied to your original list, and it does not create any new list or an updated list, but rather it just reverses the elements as it is in the original list. And then does it return anything? You don't get any return value for your reverse method. So your reverse method does not return a new list or any other value. It performs a reversal as a side effect on the existing. And then the next key characteristics is it is list specific. What do I mean by list specific? So this reverse method is exclusively available only for your list object. And if we try to attempt to use it on different data types like strings or a tuple, it is going to give us an attribute error. Do not worry about the attribute error. I will explain all these in our further chapters where we will be talking about different kinds of error, where we what we will be facing in our Python code and how to handle them using try except blocks and raise error. We have different kind of functionalities to handle these kind of errors being thrown out by your system. So do not worry about it. For now, just remember that reverse method is exclusive to our list object. Okay, cool. Let's try to check it in our code. I've got a list here which is 1, 2, 3, 4, 5. It has got 5 elements. And now what I want to do is I want to reverse it. So the syntax for my list is for reversing is same. So you provide your list name, you use a dot notation, and then you use the keyword or your function name called reverse, and then you use round brackets. All right, so that is the syntax. All right, now to my list is my name, right? My list name, so my list is equal to 1 2 3 4 5. So I'm taking that particular list and then I'm using dot reverse function, and then let's see how it gets printed. So when I print it, you can see that this is my original list, which is 1 2 3 4 5. And because an in place modification has happened, it is returning 5 4 3 2 1 when I try to print my list. So it is a dynamic language, right? So it gets updated. And as you can see here very clear, so my list has reversed it entirely. So the index position of each of your element gets changed as well. So one has been put to the last, two is to the second of last, three is in the middle, 4 has been put to your second position, and 5 to your first position. So as you see, the reverse function has reversed our. Okay, and now it's very obvious that we use 1 2 3 4 5, and hence the reversal has happened and we can see it very clear. And you might be wondering, then how is it even different to descending order? Okay, now I've got a different scenario here for you, and I've got a new list which is going to carry elements without any order. As you see here, it is 6 4 1 3 5. So it's neither denoting an ascending order nor an ascending order, right? So it doesn't comply to any kind of order. And now what I'm trying to do here is I'm using the same reverse method to see how it works for my list now. So now it is very obvious here. Your original list carries 64135, and the list exactly has reversed. So your, if I have to say in nutshell, your positional index gets reversed. So it's not exactly about the elements, but it is rather about your positional index getting reversed. So as you can see here, 64135 has been reversed to 5 3 1 4 and 6. So that is how you use your reverse function. I'll give you a bit of a glance on the reversed function as well, because we had a keyword about it. So reverse function doesn't return us any value, gives it just gives us the updated list, but not any different value or a new list. But rather, let's say you want to get your list separate, you want to pass it as a variable. In that case, you can use your reversed function. Or let's say I don't want any in place modification and I want to preserve my original list, and I want to keep my separate keep a separate list for my reversed copy. Then you can go for your reversed function. By definition, if the original list needs to be preserved, the built-in reversed function can be used. So that is reverse function, and this is reversed function. This function returns an iterator that yields element in reverse order, which can then be converted into a new list desired. So what's going to happen is we are going to get an iterator. Okay, it is going to return as an iterator where the elements are placed in a reverse order. But let's say whatever the list I have provided, I want it in a list format, then it is up to us to change these iterators back to a list. I will explain this clearly. So what I'm trying to tell here is that when you use reversed function, all your elements are returned as an iterator rather than as a list. Okay, and if you need it to be casted as a list, so all the iterator gets into a list, you need to do it by yourself. The conversion is up to us. All right, let's check with our code now. So what I'm going to do here now is I've got the original list here. My original list has values 1 6 2 7 3 8 4 9 5. So it denotes that no order has been in place. All right, and because our reversed function can return an iterator, what are we trying to do here is we are passing it in a variable. My variable here is reversed iterator. Okay, it is just a naming convention. You can have anything of your choice, it doesn't matter. So I'm using a naming convention reversed iterator, and then this is a very important, you're using a reversed function and then you're passing your iterable. So how is it different to your reverse function? In reverse function, in reverse you use reverse function, right? And then also you use your list name. So you have your list name and then you use reverse function. But when it comes to reversed function, you pass it as reversed and then you pass your list name. All right, so it's a bit different. So you pass list name dot reverse notation in your reverse method, but in reversed method you use the reversed keyword and then you pass your list in. And now what happens here is my original list gets reversed and it is shown as an iterator. To convert this iterator to my list format, what I'm doing here is I'm passing a new variable called new reversed list, and then I'm casting my iterators into a list. So casting is showcasing, or let's say there is a red color. Okay, let's say there is a red color, and if I place white screen in front of it, how it is going to be shown to you? It is going to be shown as an white object to you, right? But what is the originality of it? It is a red object. So you're casting it, you're trying to show it in a different way. So all my iterators are being casted into a list format. I'll print it here so that you get a better idea. So I'm printing my original list. Okay, this is my original list. I am printing my new reverse list, and then I'm also printing my original list just to show you that no in-place modification has taken. Okay, let's run this. So as you see here, we have got a original list 162738495. All right, and now it is getting reversed. So reversed, what happens? All your elements from a different position, the positional index gets changed. So 5, 9, 4, 8, 3, 7, 2, 6, and 1. So you can see that all your elements have reversed exactly to what you gave as an input. And when I print my original list, you can see that there has not been any in place modification. So this and your original list are similar. All right, so reverse method gives you in place modification, and reverse function will return a new copy of your reversed element. And then the next one is how to create a shallow copy. So we use a copy method in our Python list, which in turn will create a shallow copy. So what does a shallow copy mean? A shallow copy means that you're going to have a reference to your objects from your original memory. Let's talk about the key characteristics of your shallow copy or copy method. So the first key characteristics of a copy method is you are creating a shallow copy. So what happens is that it creates a new list object in memory, and the elements of this new list are references to the same elements as the original list. So let's say you have got an original list which is having different elements in it. These elements are going to correspond to a particular object in memory. Am I right? So all your objects in a list are going to correspond to a specific object in your memory. So what happens when you create a shallow copy is that yes, you're creating a copy of all your elements from your existing list, which is fine. But though they are different elements or different objects of your new list, they still reference to your previous copy. Okay, so what this basically means is that if the list contains mutable objects, changes to those nested mutable objects in one list will be reflected in the other. So what did I say about shallow copy? You're going to have a reference of the objects in memory, right, to your original list. So whatever your new list or a new copied list have you have created, it is going to correspond to your, or it is going to reference to your original list object memory. So what's happening here is when you try to create a change in your mutable object in your updated list or your copied list, what's going to happen is the changes of those nested mutable objects can be reflecting in your original list as well. So each of these elements are referenced. Therefore, any changes you do with your original list, I mean with your copied list, it will be reflected in your original list as well. And then new list object. The copy method returns a completely new list object distinct from your original list. So you are actually creating, okay, a new list object. So I said you are using copy function. You create, a copied list. Though it is a new list, the one key thing here is your new list is going to still be referenced with your old list, especially to your object method. However, your copy method is still creating a new list object which is different to your original list. The elements might be, referenced, but the lists are independent to each other. They are different. This ensures that operations like adding or removing elements from the copied list do not affect the original list and vice versa. So when I'm trying to add an element to my new copied list, or when I'm trying to remove an element from my copied list, it will not affect the original list. Or in the other way around, if I am altering my original list by adding or removing an element, it will not get reflected in my new list object, because those are new elements and they have a separate object memory. So does it take any parameter? No. The copy method is very simple and it does not take any arguments to it. Talking about the functionality, it is directly called on the list object you want to copy. It is as simple as that. So whatever the list that you have, you're just creating an exact copy of it. Okay, so let's check this now. Give me a sec. Okay, so what's happening here is I'm creating a list here. It's my original list and it is going to be of 1 comma 2 comma 3 comma 4. So you can notice here that I've got a nested element here. So I've got a list within a list. So 1 comma 2 and 3 comma 4 are one element, one single element they are. And now I want to create a copied list using dot copy function. So dot copy function is going to give you an exact copy, okay, or shallow copy in our Python context. Okay, let me run it and let me print my original list and my copied list. As you can see here, my original list and copied list are not at all different. Am I right? So just if you pay attention to the both of your lists, you can see that your original list as well as your copied list are exact replicas. Okay, fine. Because you know that your objects are getting reference to your original object memory. Now what I'm going to do here is to my copied list, okay, to this list what I've copied, that's a shallow copy. I'm trying to add number 5 to it. And what are we trying to understand here is that you remember my second point. So whenever I add a new element, it is a new list object. Okay, only whatever I've copied from my original list are going to be referenced. But when I create a new list object, they are independent to your original list. So let's see if any modification is happening to our original list after we have appended an element to copied list. So to my copied list, I'm adding number 5, and then I'm printing my original list and my copied list as well. And as you can see here, my original list hasn't changed, but my copied list has changed. But it doesn't matter. Even if I have changed this, it is not going to be reflected in your original. All right. So just in case to explain with the context of your index, this is going to be of number 0. So your index position for the element number 1 is 0. For your element number 2, it is positional index 1, and 3 comma 4, this is a single element, right? So this is going to have your positional index number 2. So all these going to be referenced to your new list as well, the copied list. So this is all the same with your copied list. But because I have appended an element at the positional index 3, it is different, and the new element doesn't get reflected in your original. Now what we will sorry about it. Now what we will try to do here is that, as you remember, we have a nested copy of your element. So this is our nested list, right? So 1 comma 2 comma is a single element, which is 3 comma 4. Now what we are trying to experiment is that if I make any changes to my nested object which I copied from my original list, does it yield any different changes? So we are going to check it out. This is a bit interesting, isn't it? So let's run our code to have a look on it. So I've got my copied list to the positional index number 2. So what is the positional index 2? So at the positional index 2, we have got the element 3 comma 4. Is 3 comma 4 is what you created as a new list object, or is it what you copied from your existing list? This is copied from your existing list, right? Which is 3 comma 4 from your positional index number 2. So it is same as in your copied list and in your original list. Now what I'm trying to do is I'm trying to access to this element. So we all saw about the concept of indexing, right? So we can choose an element based on the index position. So at number 2, in my copied list, I'm trying to append number 6. What does an append do? Append adds the particular element to the end of your. So at the positional index number 2, I'm trying to add number 6. Let's see if this activity gets reflected in our original list. As you see here, yes, this is my original list, right? 1 2 3 comma 4. Oh, as you see here, can you see this? We have got 6. So this is very interesting, right? Why have you got that? Because this corresponds or gets reference to your original object memory, and from which you have created this copied list. When you try to make changes to this, it gets reflected to your original list as well. Because the key point here is that your if you copy and list, okay, because you get a shallow copy, the copy reflects the element that are referenced in your original. All right. The key observation here is that the new elements added to our are added to our original list is not reflected, which is same for copied list as well. If you try to add any new element, it will not be getting reflected in your copied list or vice versa. If you try to modify your existing object from your copied list, it will get reflected in your original list as a say reference. So the key point here is that they are referenced, and hence you're going to find that the changes to your existing object gets reflected. And now we will talk about enumerate function. What is an enumerate? So an enumerate function, what it does is it adds an counter function to your. So what do I mean by counter function? So counter is, how do you count? You add number, right? So what an enumerate function does is that it adds a counter, so it adds numbers to an iterable such as list, tuple. So enumerate is not an exclusive function, but rather it works for multiple iterables. So talking about adding a counter, it reflects on your index value. And what happens is when you use an enumerate function, you return an enumerate object. What is an enumerate object? So as I said earlier, let's say you have a list and now you're using enumerate function. So what happens is that you're going to return an enumerate object. Enumerate object in context to enumerate function is that you're going to return a list of tuples. Okay, we will talk about it when we implement the code. You will get an idea. This object can then be used in loops or converted into other data structures like a list of tuples. So when you use an enumerate function, they can be used along with the loops. And when you use with the loops, and then later you can convert them into different data structures like a list of tuples. We will talk about it. I mean, it is a bit tough to understand, but just know that when you use an enumerate function, it is going to add a counter, and then after it includes your counter, it is going to return as an enumerate object. An enumerate object is like a list of tuples. Talking about the syntax. So syntax goes like enumerate function, bracket iterable, and then start position. So from where do you want your counter function to be worked upon? Let's see in detail. An iterable is an object where you want to enumerate. So iterable can be anything, right? A tuple is an iterable. A list is an iterable. A string is an iterable. So iterable is anything where you can loop through, where you can iterate through. So that is what you call about iterable. So first you specify your iterable object. So to which iterable object do you want to perform your enumerate function? And then start function. The start parameter, sorry, not function, it's a start parameter. The start parameter is an optional parameter, and it indicates that from what position do I want you to start the counter for your index. Okay, if you don't specify it, it is going to start as straight from your default index position 0. Okay, because in Python your index position starts from 0, right? So if you don't specify it, it is going to be started by default from 0, and then if you specify, it starts from that particular position. Let's talk about the functionality. The enumerate function allows you to iterate over an iterable. Yes, we know about it, which we just discussed, because it is going to be adding an counter function, right? So the enumerate function allows you to iterate over an iterable while simultaneously accessing the index of each item. So what's happening here is, yes, you're using an enumerate function to iterate over and each of your iterable. So what does iterable mean? So iterable is an object or a data structure, or it can be anything. For example, like a list or a tuple or a string. Anything is iterable, where you get to access each of the elements from it. You get to iterate. So anything that you can iterate, you call it an iterable. What do you mean by iterate? Iterate means that a process of looping, or the process of uh, where you go to and forth. So that is what is an iterable about. So anything that you can run an iterate function is an iterable. So what's happening here is you are iterating over the iterable, and also simultaneously what you're doing is you are assessing the you are accessing the index for each of the item. Let's say I'm iterating. For example, what does an iterate function do? My list apple. So first iteration is apple, second iteration is banana, third iteration is cherry. This is how usually a loop works. So iteration works. And what happens is, by default, when you use an enumerate function, a counter function is going to be initiated and it is going to access the index as well. So iterate apple, index 0, iterate banana, index 1, iterate cherry, index 2. So as a return, you get an enumerate object which is of index comma value. All right, so this is what I was talking about, enumerate object. So your enumerate object is going to have an index and a value. Talking in the above context, apple is having positional index 0, banana is having positional index 1, and cherry is having positional index number. And now for index comma value in enumerate function, okay, why have I given it as index comma value? Because you have to understand that your counter function is initiated, right? Enumerate function initiates a counter function. So when a counter function comes, it is going to access the element. There are two functionalities, right, in a counter function. So first thing, access the elements. Sorry, first it iterates the elements, and number two is that it accesses the index as well. So what's happening here? You're going to get two different outputs for your enumerate object. So enumerate object is going to have a counter and your value. So to access this, what you have to do is you have to use for index comma value in enumerate object my list. So you're enumerating through my list, which is an iterable here. So if you specify index comma value, then you can print it as well. So when I print this, you can see that for index the value is apple, for index value 1 the value is banana, for index value 2 the value is cherry. So it is iterating through each element. All right, so how it works? So for index comma value, so for the first iteration it goes through, okay, apple, and what is the positional index? 0. Come out, and now iterate through the list again. What is the elements again? It's banana. And what is its positional index? It's number 1. Okay, exit the code. Okay, let me reiterate. I have the value cherry now, and what is its positional index? It's number 2. So basically you are creating an enumerate object. All right, and then the final question for our day is, what is a zip function? A zip function in Python is a built-in function that makes one or more iterables such as lists, tuples, and strings as inputs and aggregates their corresponding elements into a single iterables. So zip. So how does a zip work? So zip is going to have two strips of lines at the end, and then when you zip it, they come together. When you zip, two liners come together, right? So how two strips liner come together? Similarly in Python, you might have one or more iterable, and when you use a zip function, these iterables are going to be aggregated into a single iterable. So you might have one or more iterable, and when you zip it, they all become one iterable of tuple. Talking about the key characteristics, it pairs the element. That is our first key functionality. What do I mean by pairing the elements? So the key, what happens is that when you run the zip function, it pairs with the different iterables. So you're going to have multiple iterables, right? So if you need to zip, you need two or more iterables. So what happens is that zip function always pair the first element of each input iterable together. Let's talk in our zip example. When you zip, the first, there's I don't know how to call it. So let's say first zigzag of your one line and one more zigzag from your next line. So the top end, right? So number 1 and number 1 of both your strip liners are going to get paired together. And when you further zip down, what's going to happen? The second zigzag from both of these liners get attached. Similarly, it goes in an orderly fashion that it pairs in a way that whatever the iterables that you might have, each of the elements in order are going to be zipped. For example, let's say you have 3 iterables, so you're going to have one element at each of the first positional index. So all the 3 elements from your positional index. For instance, let's say I have 1 1 1 in 3 of my iterables. So what's going to happen? It's going to zip them together, which in turn will give me a tuple 1 comma 1 comma 1 round brackets at the front and the back, right? So it pairs based on the first element or onward element of each iterable, then the second element, and so on, creating tuple of these paired elements. So it goes in order. First let's zip all the first element, let's zip all the second element, let's zip all the third element. And then what happens is that you create a tuple of these paired elements. And then what does it return? It returns a zip object, which is an iterator. To view the contents, you typically convert it to a list or another iterable type. So what's happening is in enumerate, you are getting an enumerate object. In zip function, you get a zip object, which is again going to be an. And to view all the contents of this zip object, what we have to do is we have to convert it eventually to a list or another iterable type of our choice. So what's going to happen is, as I said earlier, I think we saw that about in doing in reversed function. So when you use casting, so you're casting it based to a list. So all these iterators get casted into a list, and then the shortest iterable determines the length. Let's say you have two lines. Okay, let's go with the same zip example. Let's say your first zip is 5 centimeter and your second zip is 10 centimeter. Where does this zip stop? So you're going from first position, then you're just going onwards. Where does it stop? It stops exactly at the fifth centimeter, right? Why? Because you need at least two or three, and it doesn't matter if you, let's say you have three zips. Let's say you have an, maybe in the future, I do not know, you have three zips that you can be put together with a single zip. Even in that case, it always gets stopped at your shortest distance. So the syntax is zip function, then you mention the iterable. All right. So it can be any number of iterable. So iterable 1, iterable 2, iterable 3. So it can be any number of iterables, but what's happening is you're zipping it. So let's talk about the application. So talking about the application, you're going to have a parallel iteration. What do I mean by parallel iteration? Because you're zipping two or more iterables, it has to access the first element of each of these iterable. Talking in context to a list, let's say you have two lists. If you have to zip them together, you have to access both the elements from your both the list, right? So there is a parallel iteration happening simultaneously. And then using zip, you can create dictionaries. So how do you create a dictionary? You simply have to combine two lists, making one as a key and another as a value. So this is just an example. Okay, this is just an use case where you might use a zip. So you can use zip function to create a key and a value. And then to transpose your data. So what do I mean by transpose is that you have zipped your data, but now you want to unzip it. What do I mean by unzip it? So unzip is where you, zip is where you attach two liners, right? Where you attach two strips together. And what do you mean by unzip? Unzip is where you separate both of these strips, right? Similarly, you have to use unpacking operator. I've got an asterisk here, right? So this is an unpacking operator which you have to use with your unzip function so that your iterable gets separated. And then unzipping data, reversing the zip operation by using the zip function. And then you can see here that I've used an asterisk, which is an unpacking operator, which will split my zipped object separately to separate the elements back into their original iterable. So whatever the iterables that I got, I'm zipping it to get to its originality, or to get to its original, how it was in place. You have to use you have to use the unzipping operator so that all the elements will be returning to its original iterable. Let's see a simple example. I've got names and ages here: Alice, Bob, Charlie, 30, 24, and 30. Let me show you how I am zipping both of this. All right. So what's happening here? I'm using a variable called zip data, and this is my crucial part. I'm using zip function, and what I want to zip, I want to zip my iterables. And what are my iterables here? It's names and ages. When I zip it, and I'm also casting it to a list, right? Let's see what happens if I don't cast it as a list separately, but I'm casting it as a list so that I get it as a list of. And when I print it, you can see that first element from names is Alice has been parallelly iterated with the first element of ages, number 30. There has been a parallel iteration and it has zipped the object. So Alice 30, Bob 24, and Charlie 35 by parallel iteration. And what do I mean by list of tuples? So as you can see that at the ends we have got square bracket, which simply means that it's a list. And then tuples. So tuples are denoted by round brackets, and you can see that each of the object that has been zipped together has been created as a single tuple. So each are created as an individual separate, and then as a whole, if you see, I've got a list of tuples. Simple as that, right? And then let's talk about how to unzip our data. We have seen how to pack it. Now let's see how to unzip it. Same as above. So I'm showing you, I'm recreating an object because it is an iterator. Because as you see here, I've already casted it to a list, right? I don't want it to be a list, but rather I want it to be a iterator. So let me show you an example here. What happens if I run it without casting it to be a list? So you can see that this is my zip object, right? So is there any benefit of running with your zip object? So what you're doing, you're casting it to a list so that you get to see the iterators of your zip data. And now I want to unzip it. So I'm going to use the same iterator rather than the list. All right. So, okay. Let's unzip it. So I'm creating a zipped data with zipped names and object with names and ages. So what's happening here? A zipped object is created. Simple. And now I want to unzip it. So what I'm going to do here is I've got zip object, right? So to my zipped object, I want to separate them. For instance, to zip two of your different iterables, you named them names and ages. So let's say you got two strips, you're naming both of the strips with particular name. For example, names and then ages. Similarly, when you need to unzip it, what you got to do is you have to give the names as well. You need to create an iterable name. Based on this, it is going to be created separately. So as much as zip function is required to zip names and ages, to even to unzip, you need two different objects to be created, two different object iterables. Okay, so I'm just naming it as unzipped names, unzipped ages, and then I'm using zip function, but I'm using the unzipping operator. So be very sure about it. Okay, if you don't use it, your code is not going to run. So I'm using here my unpacking operator, which is an asterisk, and then I'm again casting it to be my list. So I want to cast my unzipped names and unzipped ages to be a list, and then I'm printing it. As you can see here, if you see this, what does it return? It returns this zip object. And from this zip object, we have unzipped it using unpacking operator, and then we have casted it to a list, and we can see that Alice, Bob, Charlie, 30, 24, 35 are created independently as a separate. All right, so that is how you unzip your original zip object. And the key point here is that asterisk is the unpacking operator when placed before an iterable like zipped data again, which contains tuples. Like, we got a list of tuples, right? In the above is a list of tuples, right? It unpacks the elements of the iterable and passes them as individual arguments to the. All right, I hope today we learned quite a lot. And do not worry about it, this is quite easier if you keep this in mind. All right, so what did we cover today? We covered zip function. Zip function, you use it when you want to create a zip object, or where you need to combine two or more multiple iterables together into a single object, zipped object. And then what did we see today? We saw about enumerate function. So enumerate function, you're going to create a counter, which in turn you will be getting as an enumerate object. So enumerate object is going to have the index and the value of your iterable. And then you know how to create a shallow copy. So you use a copy function to create a shallow copy, and whatever the new copy that you have created, the copied elements are going to have a referenced object to your original lists or original iterables memory object. So make sure that you use it in a right way. As long as you add a new object to the iterable, it doesn't matter. But if you modify whatever was originally copied, or whatever you're modifying in your original list, it gets reflected to your copied list, or vice versa. And then we saw about reverse function. So in reverse function, you get to reverse your positional index. So if you reverse the positional index, all the elements are reversed as well. And then we started with sorting. So in sorting, you arrange your elements based on a ascending or descending order, and descending is an optional parameter where you use reverse is equal to true. And then not only using ascending and descending sorting order, but also you can use a key function to specify your particular or a specific sorting criteria. And then we did check about count function. In count function, what happens? You get to check what is the frequency of a particular element within an iterable. So I hope this session was very useful to you. So do check out on our next series coming up, which will be Python interview series 5. So if you like this content, drop a like, and if you have any questions, feel free to drop your questions in the comment section, and click on the bell icon so that you don't miss on the any regular updates. And feel free to share it to your friends, who are aspiring to become a Python developer, whoever wants to even learn Python, because this is more of an interview based learning, right? It's not exactly interview. So feel free to check it out. It'll be very useful to you. So before signing off, we are Data Valley. We are the fastest growing edtech company of 2025. And we have got our headquarters in Hyderabad. We have got currently four. We have got four offline centers of excellence in Hyderabad, and then we are also planning to extend it to Chennai. Then also we have our headquarters in US and United Kingdom as well. Feel free to check in our website. We teach multiple domains like data engineering, data science, Python development, Java developer, Flutter development, ethical hacking. I can't name it. We have plenty. So feel free to check our website, and feel free to ring to our institute, and one of our colleague will catch up with you, and you can have a quick conversation and check what's happening and how would you like to progress further in your career. So that is all for today. Hope you all enjoyed. Good luck with your interviews as well. Have a good night. Thank you so much. Have a nice day.